I am Skhulile Ncube, and this lesson is proudly brought to you by the Gauteng Department of Education. Welcome to our lessons grade 10s, and let me just go through some of our expectations as we do the lessons. Okay, right. Now, grade 10s, you must have your stationery with you. This means that you must have your book, your mathematics book. You must have your calculator. We don't want to start the lesson, then you start borrowing calculators. You must have your ruler with you, and then any other thing that you need for the lesson. Even your pencils, you must have those, okay? So have your stationery with you, have your books with you. Right. The other thing, we need to communicate. We are communicating during the lesson. Please don't wait for the lesson to end. During the lesson, communicate. Even if maybe I'm moving fast, just tell me, say you're moving fast, slow down, or I did not understand this concept, please re-explain. Okay, our number is 063-508-1301. That's a WhatsApp chat for WhatsApp chats. Okay, right. And then we do activities. I'll be giving you time to do the activities. And then during that time, make sure that you utilize it. You do the activity, and then after that, we discuss and we mark our work. Okay? And we make corrections. Right? And then do not disturb others during the lesson. Do not disturb others during the lesson. I will say an important concept, then you're busy disturbing others, then people miss those important concepts. Okay? Right, I'll also give you time to discuss. If I say, let's discuss for 2 minutes, feel free. Discuss, and then after that, we continue with our lesson. Write your short notes. You don't need to write everything on the screen. Just short notes. If I say 1 minute, write short notes, just write those short notes. And then make corrections, remember, make your corrections. And then the last part, I'll give you homework that you have to do. Okay? So these are some of the expectations that we must have, and also I'm going to continue guiding you during the lessons. Okay, right, let's start our lesson, grade 10s. What are we learning about today? We're learning about the number system. Do you understand the numbers? How many types of numbers do we have, or do we deal with from grade 1 up to grade 12? How many types of numbers do we deal with? Do you know whole numbers, natural numbers, integers? Do you know how to differentiate those things? Okay, that's what we're going to learn today. The types of numbers, and then how we can identify those numbers. Right, let's go to the objectives. At the end of the lesson, grade 10s, you'll be able to recap on the types of numbers you have covered in the previous grades. You know that you learned about the whole numbers, the natural numbers, rational numbers, okay, integers. For example, if I say, what's the difference between a whole number and a natural number? Some people may not know that difference. But at the end of this lesson, you are going to be understanding the differences between the types of numbers. We are going to understand that the real numbers are actually rational or irrational numbers. I've seen this a lot, where people think that irrational numbers are not real. Real numbers are actually made up of two types of numbers, rational numbers and irrational numbers. And then we're going to discuss these type of numbers. Okay, right. And then let's go to, this is the pre-knowledge. We've done the number system, natural numbers, whole numbers, integers. And then I want us to do this activity. I'm going to give you 5 minutes, but let me tell you how you must do this. Right, drawing the table may take a lot of time. So I want you to do like this. Let's say I give you a number 2. I say 2, you can write, and then 2, is it real? You write real. Non-real, no. Irrational, irrational, no. It's a whole number. Is it a natural number? Yes, it's a natural number. Is it an integer? Yes, it's an integer. So I expect you to write like that. Just write 2, and then you write all the categories for that particular number. Now, square root of 5, you write the categories. Square root of -5, you write the categories like that. You don't need to draw the table. There's an activity where we're going to draw the table. But for now, let's just write the number and the categories. Let's do that in 5 minutes. But welcome back, grade 10s. Remember our WhatsApp line 063-508-1301. Let's communicate during the lesson. Right, let's mark our work. Okay, don't worry. You got things right, it's okay. You got things wrong, it's okay. We're learning. So as we do corrections, I'll be sort of giving you highlights about what the types of numbers. But remember, we want to understand the number system in this lesson, so that's what we're going to do. Right, the first part, let's mark our baseline activity. Square root of 5, is it a real number? Yes, it is a real number. But remember, grade 10s, a number cannot be real and non-real at the same time, okay? So it cannot be non-real. Is it rational? No, it is not irrational. 5 is a surd. Surds are irrational, okay? So irrational, and a number cannot be irrational and rational at the same time. So these first two columns is either or. It's either a number is real or it's non-real. And then it's either a number is rational or irrational. Right. And then is root 5 a whole number? No, it's not a whole number. Natural number? No, it's not a natural number. Integer? No, it's not an integer. Okay? Right. But we can have numbers that are whole numbers, natural numbers, and integers at the same time. Right. Square root of -5. Do we have any number that we can multiply itself and get a negative number? Is it possible? No, it's not. Even -2 times -2 will give us +4. You see that? So we don't have square root of negative numbers, but we're going to discuss that also as we progress. So this is non-real. A number cannot be real and non-real at the same time. And then once it's non-real, then cannot be rational, cannot be irrational, it cannot be all these once it is non-real. Okay? Right. And then -7 is real. Is it non-real? Cannot be non-real and real at the same time. Is it rational? Yes, it is. It is rational. So it cannot be rational and irrational at the same time. Is it a whole number? Is it a whole number? It is not a whole number. Okay? It is an integer actually. It's not a whole number. It's not a natural number. It is an integer. What is the difference between these two? Just wait. You will find out. Then 0. 0 is real. Yes, it is real. Is it non-real? No, cannot be real and non-real at the same time. Rational? It is rational. And then it cannot be irrational. Is it a whole number? It is a whole number. Is it a natural number? It's not a natural number. Is it an integer? Yes, it is an integer. Okay, wondering why we're saying 0 is a whole number, is not a natural number, it is an integer. You'll find out as we progress. Pi. Right, pi is a good example of a real number which is irrational. So pi is real and irrational. And then we said that once it is once it is irrational, then it cannot be whole number, cannot be natural number, cannot be integer. 4/5. It's a fraction. Integer over integer. Is it real? Yes. Is it rational? Yes, it is. Okay, we'll talk about this because it can be written in the form A/B, where A is an integer, B is an integer. Okay, I'm going to be repeating these things so that we understand them. I'm going to be repeating these things. Cannot be real and rational at the same time. So, is it a whole number? No. Is it a natural number? No. Is it an integer? No. 3 divided by 7, I think this one is just the same as 4/5. So let's not waste time on that. Right, -4,5. It is real, but is it rational? It is rational. Why is it rational? Okay, right, what type of a decimal is it? Is it a recurring decimal? Is it a non-recurring decimal? Is it a terminating decimal? Is it a non-terminating decimal? Okay, right, so it is rational because it is a terminating decimal, but we are going to discuss about this. Even 0,478 is a terminating decimal, sorry, so it is real and rational. Square root of 9. Square root of 9, that is 3. That is 3. So it is real and then rational. It is a whole number. It is a natural number. it is an integer. Okay, but here we can talk about positive 3 and negative 3. You know that, isn't it? Okay, now when you talk about positive 3, it will be like that. But when you say negative 3, then negative 3 is not a whole number, is not a natural number, but it is only an integer and rational and also real. Okay, right. Now this is our baseline activity. Now I think we have an idea about what? About the types of numbers. Now let's go deep into the different types of numbers. We're going to learn now about each of these. We're going to start with the natural numbers. We go to whole numbers, we go to integers, we go to rational, we go to irrational, we go to the real numbers, and then we go to the non-real and undefined. That's how we're going to be expanding. Okay, right. Now, natural numbers. Okay, natural numbers. I'm going to be giving you time, maybe 1 minute to write your short notes. Natural numbers start with 1. Start with 1. And increase in ones till infinity. So it goes 1, 2, 3, 4, 5, 6, 7, 8. It goes on till infinity. Those are natural numbers. They are also referred to as what? As counting numbers. The symbol for natural numbers is n. Please take note of this. In the activity that I'm going to give you, I'm not going to tell you that this is a natural number. I'll be using symbols. Please know that from now. So if you see this, you must know that this is a natural number. I'm going to be using symbols because you must get used to that. When you see an N, you must know what it means. If you see a Z, you must know what it means. It's very, very crucial. We use that a lot in mathematics. Okay, right? And then N means starting from 1, it goes on 2, 3, 4, 5, up to infinity. And then we say that natural numbers are also referred to as counting numbers. Okay, right. And then we're going to have our diagram. I don't want you to draw the diagram now. I will tell you when to draw the diagram. Now what I want you to do, you write your short notes. Leave this diagram. It's going to be expanding, growing till we get the final one. Then when you get to the final one, that's when I'm going to give you time to draw the diagram, okay, as a summary. But now, this is for natural numbers. Let me give you 1 minute to write your notes. Notes only without the diagram. 1 minute. Right, welcome back, cretins. Now we have our notes. Just short notes, don't write everything. Don't write everything. Right, now natural numbers 1, 2, 3, 4, 5. We go on like that. Then the next type of numbers is the whole numbers. What do we know about whole numbers? They start from 0 and then increase in 1. They are almost the same like natural numbers, but now the only difference is that whole numbers include is natural numbers and 0. So they start from 0, while the natural numbers start from 1. Okay, so now we have this, the symbol is n, not like that, n with a 0 subscript 0 there, or subscript 0, yes. And then please take note, I said you must make sure that you remember this, because in the activity that I'm going to give you, I'll be using symbols, right? So in your notes, make sure that the symbols are there. Right, so start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to infinity. These are whole numbers. Whole numbers. And then if you check, you can see that this part is like the natural numbers, isn't it? So natural numbers are actually a subset of whole numbers. They are inside the whole numbers. They are part of whole numbers. So natural numbers are part of whole numbers, or they are a subset of whole numbers. Okay, 1 minute to write our short notes. Right, welcome back, cretins. If I may ask, what is the difference between natural numbers and whole numbers? You don't need to write this one down. You answer it there in class. Right, what is the difference between natural numbers and whole numbers? Just answer that. What is it? The difference between natural numbers and whole numbers is that natural numbers start from 1 and you are counting in ones till infinity, while whole numbers start from 0 and then you are counting in ones till infinity. The only difference is that whole numbers have a 0 and natural numbers do not have a 0. Okay, that is the difference. Remember, I said do not draw the diagram for now. Do you see that the diagram is growing? We keep on adding to this diagram till we get to the final type of numbers, and then we're going to draw our one diagram once. Okay, just write notes for now. Integers. Do you remember what integers are? Are whole numbers integers? Are natural numbers integers? So what makes integers different from whole numbers? What makes integers different from natural numbers? Okay, right. So not natural numbers. Integers extend whole numbers to include negative numbers. Now we're talking about negative numbers. We have whole numbers. Remember, whole numbers have 0, 1, 2, 3, 4, 5, 6, going on like that, counting in ones. But now, on top of that, we have negative numbers. Okay, all right, we have negative numbers. Integers start from negative infinity to positive infinity. They start from negative infinity to positive infinity. And then the symbol, that's Z. When I'm saying x is an element of integers, you must know that x can be -1, can be -2, can be 0, can be 1, can be 3, like that. You must know that. Okay, right. And then we're saying they start from negative infinity, this side negative infinity, and then positive infinity, and then you're counting in ones. Okay, so this diagram will assist us to understand integers. So I want you to remember just these three things. When you are asked or you want to remember what integers are, just remember these three. 1, you have positive integers, which are actually the natural numbers. We have positive integers, 1. And then we have 0. 0 is an integer. Don't forget that. I'm emphasizing this because I've seen it in class where people think that 0 is not an integer. 0 is an integer. Right, the last one is the opposite of what? Of natural numbers. The opposite of natural numbers. The opposite of 1 is -1. The opposite of 2 is negative 2. I want to use that term, the opposite of natural numbers. Not to say negative whole numbers, because we don't have negative whole numbers. Whole numbers are from 0 going on, 1, 2, 3, 4, like that. Whole numbers can never be negative. Or just say negative numbers, it's fine. Negative numbers. So we have negative integers, we have 0, we have positive integers. Just remember those 3 when it comes to integers. Okay, right. You can just write your short notes for 1 minute. Welcome back. Let's remember our WhatsApp line 063-508-1301. Are we moving together, Cretans? Any questions? Any concerns? Are you understanding? Let us know. We're waiting for your input. Even your input will help us a lot. Okay, let's ask questions. Let's engage during the lesson. 063-508-1301. Integers. We've talked about integers, isn't it? Now, what do you think is the next type of numbers? What are we going to talk about now after integers? What are we going to talk about? Rational numbers. Okay, rational numbers. But let me show you a diagram. Let me show the diagram first before we go to rational numbers. So we have our natural numbers, we have our whole numbers, and then we have integers. Integers, I've just given you examples. I picked negative numbers, 0, and positive numbers. Just these are examples. It does not mean that it's only negative 3, 0, and 10. Negative numbers, 0, and positive numbers. From this diagram, what do you recognize? Are all numbers integers? Yes, because they are a subset. They are inside integers. All numbers are also integers. Are natural numbers integers? Yes, they are. Natural numbers are integers because they are inside the integers. They are inside the whole numbers. So in natural numbers, you find whole numbers, you find integers. In whole numbers, you find also integers, okay? Right. Now, let's go to rational numbers. What do you think rational numbers are? Rational numbers are numbers that can be written. Please remember this. Very, very crucial. Rational numbers are numbers that can be written in the form A over B. So common fractions, just a common fraction, 2 over 3, negative 7 over 10, those are rational numbers. Where the numerator and the denominator are integers, A over B, and then this must be an integer, this must be an integer. Just like I said, 2 over 3 is a good example. Remember this, the denominator cannot be equal to 0 because 0 is an integer, isn't it? So that's a what? A restriction there. Yes, it must be in the form A over B, but the denominator should not be equal to 0 because it becomes undefined. And then we're going to talk about that later in the lesson. Okay? Right. Do we have any numbers which are not common fractions that can be written in the form A over B? Yes, it is possible. Right, numbers like the terminating decimals and the recurring decimals. If you have your calculator there with you, let's do this. Just say 1 over 3 and then equals. And then we'll have to press SD so that it comes out as a decimal. 1 over 3 is equal to what? Is equal to 0.333333333, like that, isn't it? Do you see that is a recurring decimal? So it's 0.33333 like that, and then it means this can be written in the form A over B. It can be written in the form 1 over 3. We're not going to do that in this lesson, but in the next lessons, you have to know that we're going to be converting recurring decimals to common fractions. You can do that. So recurring decimals can be written in the form of A over B. So they are rational. Okay, the next one. Can we write, for example, 0.85 as a common fraction? Yes. How do we do that? This one is very, very easy. This gives you your numerator, and then there are many decimal places. There are 2 decimal places. So the denominator is a power of 10 with 2 zeros. This gives you the number of zeros. The power of 10 with 2 zeros is what? It's 100. Remember the powers of 10 is 10, 100, 1000, 10,000. Like 10 to the power 1 is 10, 10 to the power 2 is 100, 10 to the power 3 is 1000, like that. So that's why you say powers of 10. So this is like 85 over 100, which can be reduced to its simplest form, but we can see that it's written in the form A over B. So these two, recurring decimals and terminating decimals, can be written in the form A over B, therefore they are rational. Okay, right. And then the symbol for rational numbers is Q. Remember I said that you have to remember these symbols because in the next activity, I'm going to be giving you symbols. You must know what the symbol means, okay, so that you won't forget. Right, let me give you, I think this one is a lot of notes. Let me give you 2 minutes for this. Let's write our notes in 2 minutes. Right, welcome back. Let's go to our diagram. Remember, we're not drawing the diagram for now, okay? Right, now, is it going to expand? Are natural numbers still rational? Are they rational? Are all numbers rational numbers? Are integers rational numbers? Yes, they are, because they can be written in the form A over B. Like, let's take, for example, 2. Can be written in the form A over B, like 2 over 1. Let's say negative 3 can be written in the form negative 3 over 1. So all these 3, natural numbers, whole numbers, and integers are rational because they can be written in the form A over B. Okay, so now these are examples. 7 over 13, like that's an example. Does not mean that it's only these three that are rational, just examples. This one represents terminating decimals, they are rational, and then recurring decimals. The dot there means that 3 is recurring. These are rational. Okay, right. So whole numbers, natural numbers, integers are all rational numbers. Okay, right. But you can have a rational number which is not an integer. For example, 0.5. It is not an integer, it is not a whole number, it is not a natural number, but it is rational. Okay, right. Then let's move on to the next one. What do you think will be the next type of numbers that we're going to talk about? Is it going to be part of this diagram? Can irrational numbers be rational? They cannot be rational, isn't it? So it means we're going to have something which is now outside this diagram. Irrational numbers. Let's talk about this. Irrational numbers include numbers that cannot be written in the form A over B. They cannot be written in the form A over B. These are irrational numbers. Right. Non-recurring decimals are good examples of irrational numbers. Recurring means what? Repeating. So now if you check now, after the comma, the numbers are just coming randomly. 1, 4, 1, 2, 3, 5. We don't even know what will be the number after this 4. Non-recurring. And then we're just putting these dots here because the number is not ending. So it's non-terminating. So non-terminating and non-recurring decimals are irrational. What is to terminate? Terminate. Ending, to do with ending. So non-terminating means the decimals are not ending. It's on that in our calculators we have a certain number of numbers. Is that correct? We have a certain number of numbers that can fit on the display screen there. Otherwise, if we have a bigger screen, those numbers will just go forever. Non-terminating, non-recurring decimals are good examples of irrational numbers. And then we have very good examples of irrational numbers. These are called surds. Surds, right? Like square root of 2. If you put it in the calculator, you see that it's a non-recurring, non-terminating decimal. Right? Square root of 17. These are good examples of irrational numbers. So surds are irrational. Not every square root. Remember, we talked about the square root of 9. Don't say every square root, because square root of 9 is 3 or negative 3. Okay, right? It only says now if it's a square root of a non-perfect square. A square root of a non-perfect square, that is a surd, right? And then square roots of numbers that are not perfect squares, or cube roots of numbers that are not perfect cubes, like the cube root of 4. 4 is not a cube, but if I say cube root of 8, cube root of 8 is 2, and then cube root of 8 becomes rational, but cube root of 4 is irrational. Okay, please take note of that. And then the symbol, before we go to the symbol, pi. Pi is another good example of an irrational number, but there's something funny about pi, because pi is sometimes written as 22 over 7. Okay, is it 22 over 7? Yes, 22 over 7. So if it's written as 22 over 7, it's rational because it is integer over integer. But when it's pi like this, it is irrational. Please take note of that. Okay, and then the symbol for irrational numbers is Q prime there. Q with this thing there. Please take note of that. And then let me give you 2 minutes for this, because we have a lot of notes here. Let's have 2 minutes for our notes. Right, welcome back, greetings. I really hope that you have managed to write your notes. 063-508-1301 is our WhatsApp line. Please, let's engage each other during the lesson. Right, let's look at the diagram, but remember we're not drawing the diagram now. Right, is it going to be part of this diagram, irrational numbers? Are they going to be part of this diagram? No, because irrational numbers are not rational. So they are going, let's put them by the side here. Okay, so we have irrational numbers, and then these are examples: non-terminating, non-recurring decimals. Pi is a good example of irrational numbers. Sets are a good example of irrational numbers. Okay, so do you see that irrational numbers cannot be rational? These are two different things. But integers, whole numbers, natural numbers, they are rational. They are rational. Right. And then these two circles, we have rational. I'm saying two because the bigger one here encompasses everything, and then the irrational one. Right. These two, they make what we call the real number system. So when you're talking about real numbers, we're talking about irrational numbers and rational numbers. And rational numbers encompasses all these integers, whole numbers, natural numbers. Remember the objective that we said when we started the lesson. You have to know that real numbers are composed of rational numbers and irrational numbers. Please don't make that mistake. People tend to confuse these two now. We talk about real numbers and irrational numbers. Someone says a number is real, or sorry, a number is irrational, then now you're saying it's non-real. You can't say that. Irrational numbers and rational numbers are what? Are real numbers. We have the non-real numbers. Okay, let's talk about that, then we draw our diagram. Right, the non-real numbers are outside the real number system. Then we talk about the non-real. Please, I put them in one circle, but this means two different things. Non-real, a good example, the square root of negative numbers is non-real. Okay, and then division by 0 is undefined. Division by 0, you can write that. Just say division by 0 dash undefined. And then square root of a negative number dash non-real. Okay, right. So this system, non-real and undefined, they are outside the real number system. They are not under the real number system. Okay, right. Now, I want us to have about, let's say, not say about, otherwise, 3 minutes. We're having 3 minutes to draw our diagram. 3 minutes to draw our diagram. Make it big, maybe half a page. Okay? 3 minutes, let's draw our diagram. Right, welcome back, grade 10s. Now it's time to apply what we've learned. Okay, this is the main activity that I want us to do, and I'm going to give you enough time so that you get everything correct. Okay, right. Now you can refer to your notes. You can refer to notes, but it is my wish that you remember what N is, what N naught is, what Z is, what Q is, what Q prime is. Because I told you that you must remember those symbols, okay? Right. Now, I'm going to give you 3 minutes to draw the table and write the numbers and also the symbols. Let's do that in 3 minutes. And then after 3 minutes, I'll come back and tell you what to do. Let's do it. 3 minutes. Just draw the table, write the numbers, and write the symbols. Let's try that. Right, welcome back, grade 10s. We are doing the activity now. You should be having your numbers with you. Now you are tick the correct column. Like 3/4 there, is it a natural number? If it is not natural number, leave it blank. You don't need to put X. Is it a whole number? Is it an integer? Is it rational? Is it irrational? So tick the appropriate column. Let's do this in 4 minutes, and then after 4 minutes, we're going to mark our work. 4 minutes. Right, welcome back, grade 10s. Let's mark our work. Please make corrections as I give you the answers. Okay. Right, 3/4. It is rational. Okay, it's not an integer. Okay, it's not a natural number, it's not a whole number. It's rational, and then it cannot be rational and irrational at the same time. 0.725 is a terminating decimal, so it's a rational number. Square root of 81, that is 9, so it is a natural number, it is a whole number, it is an integer, and it's also rational. Okay, please make those corrections. 1,125, this is rational. Why is it rational number? Because it is a recurring decimal. Those they mean that 1,125, 125, 125, 125. So that is rational. The -2/5 is a rational number because it's integer over integer. It can be -2/5 or 2/-5, just same thing. And then pi, because of this pi, so it becomes irrational. And then square root of 17, that's a third. Sets are irrational. And then 0.3216341 going on like that. It's a non-terminating decimal, so that is irrational. Right, so these are the real numbers. Okay, the real numbers. We only talk about rational and irrational numbers, right? But remember these grade 10s, I say that division by 0 is what? Which one do we pick there? From these four: irrational, non-real, rational, and undefined. Division by 0 is undefined. Don't forget that. Division by 0 is undefined. And then square root of a -4, square root of a negative number, that is non-real. That is non-real and undefined. And then 22/7, I think this is repetition. That is rational because integer over integer. And then because of the pi, 3pi becomes irrational. Okay, right. I want us to take a short break, and then when we come after break, we're going to summarize our lesson. Let's take a short break.
Attitude of gratitude. What does that mean? An attitude of gratitude is the quality of being thankful. It's the quality of giving thanks. Ubonga, ulebuha. It's to be grateful. You and I have so much to be grateful for. You and I have parents who make sacrifices day and night for us to be at school. You and I have people who believe in us when we don't believe in ourselves, who love us when we don't love ourselves, who invest in us day and time again. Whether it's a teacher, it's a principal, it's a driver, it's a guardian, we have so much to be grateful for. And so I challenge you, young person, be thankful. Ubonge, lebuha, be grateful each and every single day of your life. Strive to display an attitude of gratitude.
Right, welcome back, grade 10s. This is your homework. You are applying what you have learned. It's just application. Okay, it's not a new thing. We're applying what you have learned. So now, what you do, you can come back to this point where there's homework and copy it. I just want to go to summary, and then later on you come back, and then you can copy your homework and do it, and maybe consult if there's something you don't understand. Right, so this is your homework. If you can take a screenshot now, you can do that. But if you want to rewind and come back to this point, you can do that also, it's still fine. But now let's go to the summary of our lesson. Right, what did we learn today? There was no discussion. Please, next time, let's come prepared to discuss. During lesson, we engage each other, ask questions, feel free. Right, and then let's summarize our lesson. We say rational and irrational numbers are what? Are real numbers. Please keep on referring to your notes. And then natural numbers start with 1 and increase in 1 till infinity. Then whole numbers start with 0 and increase in 1s till infinity. And then integers extend whole numbers to include negative numbers. When I'm saying whole numbers, already the 0 is included because 0 is part of whole numbers. And then rational numbers are numbers which can be written as a fraction, a over b, remember, but a must be an integer, b must be an integer. And then irrational numbers cannot be written as fractions. Thank you very much, grade 10s. We have come to the end of our lesson. We are meeting next week. Don't miss the lesson. Next week on Thursday, 9 a.m. And then in our next lesson, we're going to be doing a very, very crucial concept. We're going to look at the difference and sum of two cubes. You need to attend that lesson because it's a very, very crucial concept that you need to understand. Let's meet next week, grade 10s. Goodbye.